Previously, we graphed functions using transformations. In order to do so, a quadratic function needs to be converted from standard form into vertex form, or sometimes called graphing form. So here are properties of the graph of quadratic equation. Given f of x equals ax squared plus bx plus c, where a does not equal 0, the vertex h comma k is the opposite b over 2a, comma f of the opposite b over 2a. So in other words, if I have a quadratic equation in standard form, I can find the x-coordinate h of the vertex by using the opposite b over 2a. It's like the quadratic formula without the plus or minus square root part. Once I get that number for h, I'm just going to plug that number in for h back into my quadratic equation to get the y value, the k value. The axis of symmetry is the line x equals h equals the negative b over 2a. And again, just a reminder, if a is greater than 0, I think of my smiley face. Vertex is the minimum point, k is the minimum value at x equals h. And if a is less than 0, the vertex is the maximum point, k is the max value at x equals h. And what you want to notice here, when we talk about the discriminant, what was underneath the radical in the quadratic formula, it's going to determine the number of x-intercepts the quadratic functions have. When it's greater than 0, then your quadratic function is going to have two distinct x-intercepts. And your graph is going to go through those x-intercepts. When it's equal to 0, then you just have one x-intercept, which is going to be at the vertex. And if it's less than 0, then the quadratic function is going to have no x-intercepts. So let's go ahead and get back into the workbook problems. Let's take a look at number 5. We want to find the vertex of a problem by using the vertex formula. So here's just a reminder, quick reminder what we're going to be using. We're going to be using h equals the opposite b over 2a to get our x value. So number 5, we're given f of x equals negative 3x squared plus 48x minus 105. And we want to determine the vertex by using the vertex formula and write the equation in vertex form. So the first thing I do is I'm going to whip out my vertex formula. And here, my a value is negative 3. My b value is 48. So I'm going to plug that in. So we'll plug in 48 on top for b. Plug in negative 3 on the bottom. That will give us negative 48 over negative 6. If we do that division, that's going to give us 8. Now to find my k, I'm going to take this 8 and I'm going to plug it back in for x. So my k value evaluate this 8. And let's go ahead and punch that out on our calculator. So we have negative 3 parentheses 8 squared plus 48 parentheses 8 minus 105. So that gives us 87. So our vertex is 8, 87. Now they also asked us to write the equation in vertex form. Remember, vertex form is f of x equals a times x minus h squared plus k. Now remember what my a value is. Back up here. That's my a value. That's going to be the same a down here, so that's negative 3. We just found h and k, so we're going to plug those in. 8 and 87. Thank God we don't have to graph that. We'd have a stretch by a factor of 3. Then it would be reflected vertically across the x-axis. We'd have to shift right 8 and up 87. Now, if you just think about it visually, my graph would be way up here. Notice it will not have any x-intercepts because it's up here. All right, let's try some applications. At the end of his career, Sherlock Holmes retired to a small farm in the country and took up a hobby of beekeeping. Being of an analytic mind, he would not just watch a bee fly from flower to flower. He formulated mathematical for the parabolic path for the bee follows from flower A to flower B. The height in inches above the ground is given by f of x equals a negative 0.03 x squared plus 1.2x plus 30, where x is the distance in feet the bee is from Sherlock. What is the maximum height the bee reaches as it flies from A to B? Now, anytime you're working with a quadratic formula or a quadratic function, and they're asked you to find a minimum or a maximum, you want to immediately think, I have to find the vertex. So the first thing we're going to do is we're going to find the vertex. So I'm just going to calculate h is the opposite b over 2a. My a here is this negative 0.03. Guess I didn't give myself enough room, so let's clean that up. My b here is this 1.2. All right, so let's go ahead and put this in our calculator. So we get 20. So h would be 20. And remember, h corresponds to the x value. So that would be 20 in distance in feet from Sherlock. Now we find the k value. So now I'm looking for my function value. I'm going to evaluate my original function at 20. So let's go ahead and plug in 20. And let's go ahead and whip out our calculator. So that'd be 42. And the y value is the height, so this would be 42 inches above the ground. Okay, so let's see what we want to know what the maximum height the bee reaches, so that would be 42 inches. That's answers to part A. Part B, how far away is the bee from Charlotte when it reaches the maximum height? Well, we found that was 20 feet. Let's try another one. A child kicks a ball into the air, and the height of the ball, y, in feet, can be approximated by y equals negative 16 t squared plus 40t plus 3, where t is the number of seconds after the ball is kicked. Find the maximum height of the ball. So again, maximum, or if it's at minimum, I would be needing to find the vertex. So that's my first thing I need to do. So we'll just go ahead and plug in. Again, we could do this on our calculator. And tell you what, let's go ahead and do this as a decimal. And there's no rounding here, so this is just going to be equal to 1.25. And t is the number, we found the t here, so this is actually seconds. And so actually, we already got the answer for part B. So let's get part A. So we're going to plug in this 1.25 for t. And now let's go ahead and calculate this. So that gives us 28. And so that's the answer for the first part.